Hello students, welcome to EII. So hope you are all doing fine and preparing good for your upcoming exams. So today our topic is adsorption under the subject mass transfer. So it is very important from the gate point of view. So we'll look into it what's there. Okay. So the basic definition of adsorption is that we try to separate a solute from either a gaseous mixture or a liquid mixture with the help of a solid adsorbent. The solid adsorbent provides surface area for the adsorption, that is this solute gets adsorbed on the surface of the solid and it gets separated from the mixture either in the gaseous phase or in the liquid phase. So like there's an example like suppose we have a beaker and in the beaker we have a color and water mixture and we put a activated carbon in it. So what will happen, the color molecules will get adsorbed on the activated carbon and we will get a clear water solution. So here the activated carbon acts as the adsorbent and the color molecules like the solute, they act as the adsorbate. So keep this in mind that the substance or the solid on whose surface the adsorption occurs is known as adsorbent, and the solute which is getting adsorbed is known as adsorbate. Okay. So now this adsorption is directed by generally two laws according to our syllabus. The first one is the Langmuir adsorption isotherm. So the Langmuir adsorption isotherm is generally based on the partial pressure and it generally directs the solute when it is in the gaseous phase. So we can see that Q is equals to AP plus 1 divided by 1 plus BP. Okay. So this is our general formula. So this is our general formula. Okay. Yeah. So let's see. So this is our general formula of our Langmuir adsorption isotherm, that is Q is equals to AP divided by 1 plus BP. Now what are all these terms is that A and B are arbitrary constants which depends on the temperature of the system, and P is the partial pressure of the system. Now as I already told that as because this Langmuir adsorption isotherm generally deals with the solute when it is in the gaseous phase, so the partial pressure will play an important role in this. Okay. Now what is this quantity Q? This quantity Q, it is the kg of the adsorbate adsorbed divided by per kg of the adsorbent we are using. Means suppose that we are taking a beaker, and at the same example beaker we are taking and we are starting with a color and water mixture solution. So suppose we are using activated carbon, suppose we are using 5 gram activated carbon, and the amount of color solutes or the color molecules that are getting separated weighs only suppose 0.05 gram or something like that. So our Q will be 0.05 divided by 5. Okay. So this is our Q. So remember this. So this was our basic adsorption Langmuir adsorption isotherm. So based on this we can take up a question. Yeah, here's the question. So let's try to solve it. See, what's given in the question is that at 30 degrees centigrade the amount of acetone adsorbed at partial pressures of 10 and 100 mmHg are 0.1 and 0.4 kg acetone per kg activated carbon. See, this thing, that is kg acetone per kg of activated carbon, this unit is Q's unit. We can see it clearly, it is unit of Q. So that means we can say, and here two values of Q are given. Suppose we are noting it as Q1 and we are noting it as Q2, and also two partial pressures are given, so we can note it as P1 and this one as P2. So we can write according to our formula that Q1 will be is equals to A P1 divided by 1 plus B P1, and Q2 will be is equals to A P2 divided by 1 plus B P2. Okay. Now so our formula will turn out to be 0.1 is equals to A into 10 divided by 1 plus B into 10, and here 0.4 equals to A into 100 divided by 1 plus B into 100. So we are saying that we have got two equations and we have two unknowns, that is A and B. We will solve these equations and we will find the values of A and B. Now once we find the values of A and B, what we do, once we find the values of A and B, what we will basically do is that we will find out Q3. What we assume Langmuir adsorption isotherm describes the process, and what is the amount of acetone adsorbed at a partial pressure of 50 mmHg. So we have to find out Q3, which is basically designed at P3. And what is the P3 value? It is 50 mmHg. What is the P3 value? It is 50 mmHg. So we have found out A and B from the from these two values that were given. A and B are known now, and we have to find out Q. This is our unknown, and V, this is our unknown, and we know the value of P3, that is 50 mmHg. So we will just put it in this equation and we will find it. Okay, so its answer, I think it's coming out to be 0.3. Okay, and this is a GATE previous year question. It is a GATE previous year question. Okay. Okay, now let's go to our next topic. Let's go to our next topic, that is French adsorption isotherm. So first one was our Langmuir adsorption isotherm, and the second one is the French adsorption isotherm. So what it states is that Q is equals to, what it states is that Q is equals to Kc to the power n. Okay, now what is K and n? Now these are again constants that are functions of temperature only, and this C is the concentration. Now see, the moment we have seeing the concentration, we can tell that as because in the Langmuir one the solute was present in the gaseous phase, here as we are dealing with the concentration, the solute must be present in the liquid phase. So it is wrong, it is written wrong, it will be liquid phase. Okay, as because it is in the liquid phase, therefore we are dealing with the concentration. When it was in the gaseous phase, we were dealing with the partial pressure. Okay, and again all the things have same meanings. The Q is the same, that is kg of adsorbate adsorbed per kg of adsorbent. N and K are constant, and C is the concentration of the solute. Okay, now let's move forward. Yeah, so this is very important topic from our GATE exam point of view, as because many times questions from this has been asked. So this is batch adsorption. So what is batch adsorption? So this is Ci minus Cf this is Ci minus Cf into volume is equals to W into Q. Now let me explain all the terms. This Ci is the initial concentration. Ci is the initial concentration of the solute present in the mixture. Suppose we are taking a beaker, again the same example, we are taking the beaker and we are preparing a color and water solution. So the concentration, initial concentration of the color in the water color mixture, the solution, that will be our Ci. What is Cf? That once our adsorption is finished, then the final concentration of the solute, or the, suppose in this case the color present in the color water mixture of the solution, is known as our Cf. This V is the volume of the color water solution mixture. Now we can understand that this volume is generally dictated, or this volume is generally dominated by the volume of the water only, or the volume of the solvent only, as because the solute has very little role to play in this volume. And this W is the amount or the weight of the solid or the adsorbent that we are using. For example, we were using activated carbon. So this activated carbon, the amount of activated carbon that we are using, suppose 5 gram, that is given by W. And this Q is again the same thing, that is kg of bit adsorbed per kg of adsorbent. Okay. Okay. So let's solve a numerical on this, so we will get a better idea. Yeah. So what is given is that adsorption on activated carbon is used for reducing phenol concentration in waste water from 0.04 mole per liter to 0.008 mole per liter. So from here we can directly write that Ci is given as 0.04 and our Cf is given as 0.008. Okay, so our Ci and Cf is known. Rest what is known? The adsorption isotherm at the operating temperature can be expressed as Q is equals to 0.025 C to the power 1 by 3. This is the adsorption isotherm, where Q is the phenol concentration in the solid. Q is the phenol concentration in the solid, that is mole per gram of solid. Okay. Now see, sometimes we can denote it by the kg of adsorbate adsorbed per kg of adsorbent, or we can do it by mole also. We will just I will just explain it to you. It may be confusing to you. I will just give you a brief idea that how it's happening, so it will be more clear to you. See here. So what is our formula? It is Ci minus Cf into V, that is equals to W into Q. So let's just do an unit balance so that you can understand. Suppose this C's unit is mole per liter. This unit will also be mole per liter. Volume unit will be in liter. W unit will be suppose gram, and this Q unit was mole per gram of solid. What is W? The amount of adsorbent only. So this it is what? Gram of solid, and this one is also the gram of solid. So this one will cancel out, and here liter will cancel out. So see, mole, and here also mole. So the unit is balanced, and we know that in chemical engineering unit balance is very important. Many questions come in the exams that we can directly solve only through unit balance. Okay, so this is clear. Now let's go back to the numerical part. Yeah, coming back to the numerical part, we knew that our Ci minus Cf into V is equals to W into Q. So our Ci value, it is given as 0.04, Cf value it is given as 0.008, volume it is given as, okay, volume it is not given, it is said to find out per liter. So volume we will consider as 1. W we have been told to find out. We have been told to find out the minimum amount of solid to be found out. So W we have to find out. This is our unknown. And Q, it is directed by Q is equals to 0.025 C to the power 1 by 3. Okay. Now see here, one more term is used, that is the minimum amount of solid. So whenever minimum amount of solid or the equilibrium amount of solid will be mentioned in the question, at that point we can directly assume that this C must be the Cf or the C equilibrium. This C final, that is once our adsorption is completed, if we the final concentration of the solute, that C and this C will be the same. Okay. So now let's go on forward. So we will find out Q is equals to 0.025 Cf to the power 1 by 3. From here we will get the value of Q. Cf we already know. We will put in this equation and we will find out W. We will consider it 1. Cf is given and Ci is given. Okay. So this type of question, this is also a previous year question for GATE. This has also came in GATE previous year in the year 2018-19, something like that. Okay. So these two questions, these two are only the type of the questions that have came from adsorptions in GATE till date. Okay, I'll just give you one more question for homework that you can try on your own. Yeah, it is like the same question only. You can try to do it on your own at home. Okay, so that's all for this lecture. If you we will again come back with some other lecture with some other topic, and if you want to get lectures on some specific topic, then you can directly comment it below the video. Thank you.